Hello everyone and welcome back. My name is Mr. Cobalt and I'm going to be going over in this video the second practice problem dealing with collecting a gas over water. So let's go get into this problem. So hydrochloric acid reacts with metals, in this case zinc, to produce hydrogen gas, and then the hydrogen gas is collected over water. So suppose a student carries out this reaction and collects a total of 154.4 milliliters of gas at a pressure of 742 milliliters of mercury and a temperature of 25 degrees Celsius. What mass of hydrogen gas in milligrams does the student collect? So one of the things we have to keep in mind is when they say you collected over water, that water vapor is part of the mixture, and so therefore you have to use Dalton's law of partial pressures to subtract out the water vapor, so that way you have only the pressure due to the hydrogen gas. So we need to find the pressure of water vapor at 25 degrees Celsius, so that has to be something you look up on a table. So I'm going to look that up on the table right now. And so at 25 degrees Celsius, that's going to be 2378. So the partial pressure of water at 25 degrees, again, is 2378. So 2378 millimeters of mercury. So that is the water, that's the pressure that's the partial pressure of water. So I gotta subtract that out from the total pressure collected here. So we take the 742 millimeters of mercury, we're gonna subtract out the water vapor, and we have 23.78 millimeters of mercury. And so we calculate that to be 742 minus 23.78 equal, oops, I forgot to turn on the calculator, 742 minus 23.78 equals, and that's 718.22, so that's going to be 718.22. Okay, so we got to keep track of our significant figures, and so when you're adding and subtracting, it's the least number of decimal places. So 2 decimal places, 0. So this is the last sig fig in our answer. But we're going to keep that because we need to continue with our calculation. So this is millimeters of mercury. And so now that I have the partial pressure, I want to use that in the ideal gas law because they're asking for mass of hydrogen gas. I need to get to moles of hydrogen gas, and I can use the ideal gas law if I convert this to atmospheres. So let's convert that to atmospheres. So we can kind of do that here. So if I put this over 1, we'll do it here. So 718.22 millimeters of mercury over 1, and then again 1 atmosphere is equal to 760 millimeters of mercury. So 760 millimeters of mercury is on the bottom, 1 atmosphere is on top, so millimeters of mercury cancel out. So now I can calculate. So I'm going to divide this by 760 equals, and I get 94.5026. So, oops, 94. So 0.945026, and that's atmospheres. And again, check my sig figs. I'm only allowed up to the 8 because 8 was my last sig fig. So I have 3 here. This is exact relationship, so I don't need to worry about that. So 3 is my answer. So 945. So it stops there. But again, I'm going to keep this because I got to use this in a further calculation and I don't want a rounding error. So now that I have my atmospheres, my partial pressure of hydrogen in atmospheres, now I can plug that in with the other information. I have to change the volume though. So the volume is in milliliters. I have to change that to liters. So if I equate my milliliters and liters, I always put a 1 with the milliliters, and the prefix multiplier goes with the base. So milli is 10 to the negative 3, so that's going to go there. Now, I'm going to use that to convert my volume. So I have 154.4 milliliters. Okay, so milliliters is going to go on the bottom since I have it on top. So 1 milliliter, 10 to the negative 3 liters. Milliliters cancels out, so that way I get 0.1544 liters. Okay, so looking at sig figs, this is exact, and this is 4, so I have 4, so that's fine. So everything's good so far. So now I have liters, I have atmospheres, I need to convert temperature to Kelvin. So I'm going to take 25 degrees Celsius plus 273.15, and that's going to be 298.15 Kelvin. And again, if I'm adding, that means I'm looking at decimal places. So I have 2 decimal places, 0 decimal places, so the least number is 0. So my last sig fig is the 8 there. Okay, so now I have Kelvin, liters, atmospheres. Now I can plug it into the ideal gas law to find number of moles. So again, the ideal gas law is, I'll write here, PV equals nRT. So I want to look for moles. So moles is going to be equal to, or at least the moles of hydrogen is going to be equal to pressure of the partial pressure of hydrogen times the volume divided by R divided by T. So then if I write this out, the pressure is 0.945026 atmospheres. Again, we don't need to carry all the numbers. I could have stopped at 0, but I am anal. Volume is 0.1544 liters divided by the R constant, 0.08206 liter atmosphere over mole Kelvin. Multiply, okay, where's temperature? 298.15 Kelvin. Okay, so atmospheres cancel out, Kelvin cancels out, and liters cancel out, leaving moles, which is what I want. So if I go to my calculator, so I'm going to multiply everything. So moles times 0.1544 divided by 0.08206 divided by 298.15 equals, and I get 0.0063, 0.0063, 107 moles of hydrogen. So now I have moles of hydrogen. Let's look at our sig figs. Again, for the moles, 5, my significance ends at the 5. This is good. My significance ends at the 8 there. So I have 3 sig figs. I have 4, 3, 4. So the least number is 3. So my significance ends at 1, 2, 3 at the 1 here. Okay, so I have moles of my hydrogen gas. They want milligrams. So I need to go from moles to mass, so I need to use the molar mass. So I'm going to need to create some space here. So let me erase this. So now I have moles. So I have 0.006310.7 moles of hydrogen gas. So I want to convert that to mass. So we use a molar mass. So H2 is going to have a molar mass of 2.016 grams per mole. So I'm going to want to put that on the top. So 1 mole of H2 on the bottom to cancel out with H2 on the top. And then I'm going to have 2.016 grams of H2 on the top. So moles cancel out. But now I have grams, but I want milligrams. So once again, I'm going to use my relationship. So I have milligrams. Let's bring this over here. So I have milligrams. So a certain number of milligrams is equal to grams. I always put the 1 with the unit that has the prefix, and then the prefix multiplier goes with the base unit. So milli is 10 to the negative 3. So there's my equality that I'm going to use. So grams goes on the bottom, so 10 to the negative 3 grams goes on the bottom, and milligrams goes on top, so 1 milligram. So grams of hydrogen, I should write hydrogen here. So grams of hydrogen cancel out, and now I have milligrams, which is what I want. So now all I need to do is calculate. So this times 2.016, and then divided by 10 to the negative 3. So then divided by 1 times 10 to the negative 3 equals, and so the number of milligrams, is equal to 12.722. 12.722 milligrams. And then I need to double check my sig fig. So remember the 1 here is my last sig fig. So I have 3 sig figs here. I have 4 here, and this is exact, so I can ignore that. So 4 and 3. So the least number is 3. So this is my last. That's my final answer. So 12.7 milligrams of gas, of hydrogen gas, is what was collected. I hope this is clear. I hope it was helpful. If you like this video, like it, share it with your friends, subscribe to the channel, make a comment down in the comment section. Let me know what you think, and hit the notification bell so that way you're notified by any other videos I put out. Thanks for joining me, and I'll see you next time.